definitely need a bigger clock. All right, we're live. This is Retrace, segment number 66 for Wednesday, November 30th, 2022. It's 11 p.m. Eastern, 8 p.m. Pacific. Retrace is about what's going on out there. It's a podcast. You didn't know that, but now you do. The short answer to that question is computer control. The long answer is natural, artificial, and strategic intelligence, by which we mean strategic intelligence means espionage stuff. And also there's humanity, which is the best part of what's going on out there. Retrace is for outsiders, but we came to the conclusion that outsiders are not players and the computer control game is player-oriented. So now we're learning to play. Always be coding. ABC, always be coding. AIDA, attention, interest, decision, action. Do I have your attention? I think I do. Are you interested? I forgot the rest of it. I love that movie. Okay. If I've got you back today, that's fantastic because I know yesterday was kind of tough. Today's going to be better, more fun. Okay, so we're going to get into we're going to run the code that corresponds to this, what you see on screen here. On the left-hand side, you see the pseudocode from AIMA4e, Artificial Intelligence and Modern Approach, 4th edition by Russell and Norvig. We're in the beginning of a big program of study of that book, but we're using it to learn something. We're not being faithful to it. We did not marry this book, but we're dating it. On the right-hand side, you see the implementation in Python, or their implementation. I had to tweak this thing to get it to work, and I'll show you that momentarily. But roughly, the highlighted stuff on the left corresponds to the highlighted stuff or the boxed-in stuff on the right, and that's what we worked on yesterday, or what we established yesterday. Tried to make sense of a little bit. Today, we're going to do that, run that on a computer. And the program is, let's say, okay, well, we'll call it so let's go back to yesterday for just a second. Can I get to the, thank you. Is that it? That's not it. What is that? That's not what I wanted. Oh, for Pete's sake. That is not what I wanted at all. I closed the wrong thing. Okay, so Emacs. Oh, geez. Well, you might as well watch what I'm doing, right? This is fun and games. What I need to do is work on some... are you sure you want to? No, I don't want to do that. Oh, my gosh. I knew something was going to go wrong. I should have warned you. Okay, so we're going to go to segments. And we're going to go to... No, we're going to go to live there. And CD, Re, and Emacs... the amendment thing. There we go. Okay, this is what I wanted to show you or work from. There you go. You got it. Okay, so yesterday, now I'm going to turn it off. Now I went to all that trouble. I'm going to turn it off. Once I get my little clicky right there. Okay. We used some lingo yesterday, things like dictionary, memory object, and then we used the word function in like 3 different senses, the computer program function, a math function, and then an agent function. Briefly, I just want to say, like, first of all, our lingo, our vocabulary and the accuracy of it is going to, and the nuance is going to improve over time. It wasn't bad, but I said at one point, initiate a memory object or initiate a dictionary. It's initialize. I knew that, but sometimes I say initiate, but it's initialize. Don't say initiate. What is a dictionary? I'm just going to put my notes up so you can look at them if you want. A dictionary is a Python thing. It's a container in Python. It's a kind of container in Python, which is a container is an alternative to a variable. It organizes the data. Instead of a variable, you can just make it a word or a number or a string, anything you want. But there's no organization to a variable if you don't impose any structure on it. A container imposes structure on a variable, and a dictionary is one of the ways you can do that. Other ways are lists, tuples, etc. And the data structure, the computer science data structure that a dictionary is an associative array. I just want to, we got to get accurate about what we say here. Memory object, I'll just leave my notes there. I'll put them in the body of the notes as well. But just be careful how you say things. Don't repeat what I say. Don't repeat what I say. That's the key. Don't repeat what I say. And then also, I just wanted to call out one more time. Computer program function is basically like an input-output machine. A math function is sort of like that, except it describes a relationship. Instead of being a machine, it's sort of a description of a relationship. And then an agent function, which is an artificial intelligence term, is the part of the agent program that makes it smart. So what do I mean by that? Let's go over to the screenshots here. So if I pull them up on, I can highlight if I do that. Okay, so no, can you see that? Yeah, good. So this whole thing here is the agent program, and this whole thing, which I'm actually getting some highlight in there, just barely. Actually, not the whole thing. This I would call the agent program down here. This, yeah, you're not really seeing my cursor. Anyway, the part of this that's the agent function, the part that makes it smart, is in the case of the pseudocode, it's the table, and in the case of the Python code, it's also the table. The point being, you're going to look at programs throughout this course of study, and throughout your artificial intelligence life, or the life of your understanding the details of artificial intelligence. But you need to understand that most of the program code, most of the lines of code that you see early on, especially, are not the smart parts. They're not the dumb parts. They're the precise parts. So if you think of regular computer programs as being steps for arriving at a precise answer, artificial intelligence computer code or programs are steps for improving on an approximate or a approximately good answer. So improving on a good answer or improving on any kind of answer. It's improving a result as opposed to finding the precise result. Finding the precise result is classical computer programming, and improving on an approximate imprecise result is artificial intelligence programming. That's one way to think about it, okay? So if we jump over again to our pseudocode here, all these lines, except for the container that is the table, everything here is good old-fashioned precise computer programming. But the table is our meager first, just out of the box, page 48 attempt to make it smart by improving on a. Now the table doesn't really do it. I mean, it's a terrible, I guess, example of what I just described. But that's how we should compartmentalize regular code versus artificially intelligent code. Okay, let's run the code. I'm going to run the code, and something's going to go wrong, and we'll get past it. Don't worry. But then I'll explain it. Okay, so let's jump over to our IPython interpreter. Okay, so on the left-hand side, you see just my flashing cursor, and I'll tell you everything I'm using maybe later. I don't know, but you see a lot of things going on here. But all you need to understand is on the left-hand side of the screen, that whole blank area right now, is where we're going to interact with the computer. And on the right-hand side, this whole area right here is just a text document, basically. I'm just going to copy stuff from my text document over here so I don't, type it wrong and waste your time. And then we'll go from there. So let's run this program. So I'll explain why there's a lot to this after I just run it, okay? So just watch what I do here. I'm going to take this table. This is what my copy-paste is going to look like. It's just using tmux if you're interested. Okay, so I'm copying. Whoops, no, I don't want to do that. I don't want to do that. I want to go into IPython first. IPython interpreter. It's just a better Python interpreter so that you can recall multi-line commands and you get syntax highlighting and stuff. But just think of this as interacting with the Python, CPython, the Python interpreter. Okay, no, I don't want that. There we go. Okay, so what I've just done is I've pasted our table. This is a list. It's not a list. It's a dictionary, and I've organized it so that each line is a percept sequence, and then the action that I want our artificial intelligence program to return when it receives that given percept sequence. So our first percept sequence, as we discussed yesterday, was the word red, and then if our table agent receives the word red, I want it to return thumbs up. This is me putting intelligence into the thing. It's not really. I know no one would think this is a real AI program, but it's just to get the scaffolding around how we think about these things. And then if it receives red again, that means it appends red to the second red to the first red. Now it has a percept history of 2 reds, and I want it to say yes, like it's interested. Yes, 2 reds. Okay, our AI is interested in what we're doing. Oh, now it receives a green. Okay, yes. For some reason, this AI reminds me of Wayne Campbell from Wayne's World. All right, and then finally, as we said yesterday, red, green, red. Those 3, those 4 percepts: red, green, red. Oh, that's a thumbs down, right? We want to return a thumbs down, a big one. Okay, so now I've pasted that in. I'm gonna send that to IPython, and now it's in memory as the table. So if I just type table, I'm gonna clutter the screen, but we gotta do this. Okay, if I just type table, the nice thing about IPython is it returns my dictionary. Okay, now what are we gonna do? Now we're going to, and I should say, obviously, I'm not using their code. I'm borrowing from their code, but I'm not just running their code for lots of reasons that we'll talk about, I guess, later or some other time. Hopefully we'll come back to that, but I don't know. No promises. Okay. This code I built myself, and this is the first out of 3 versions that we're going to run to make sure we understand it. Okay, so let's take this list. It's got a square bracket, so we know in Python that means it's a list. Just paste it over into IPython, send it. Okay. Now IPython has in memory a list called percepts. Let's just make sure that there's nothing in it. Okay, good. Now let's go over here and let's send our IPython / agent experience over here. Let's send it a percept. Let's send it red. Okay, so all we've done here is created a variable called percept and set it equal to the string red. Okay, so right now in memory over here we have 3 objects in memory: a table, the dictionary that we've labeled as table, the list that we've labeled as percepts. Okay, so this dictionary, okay, that right there, table, and then we've created an empty list called percepts, and we also added a percept to the environment for our agent, which doesn't exist yet over here in this IPython instance. Okay, now what we're going to do, because we're sort of like turning each gear of this artificial intelligence program ourselves. We're not running it all as just one big function. We're doing it manually just to start. We're going to use the append method, to append the percept variable to our percepts list. That's all this line does. Okay, I'm just going to do that, and now you're going to see when we type percepts and we don't autocomplete the whole thing. Oh, look at that. Now our percept history is red. That's our percept history, okay? Now there's nothing, there's no AI, there's no agent program that knows about it yet because we're sort of inside of it. We are running this agent program step by step. We will do it all in one go in a second. Okay, now we need to set our action equal to the result of table.get. So the get method applied to the table, and what does it get from the table? It gets the tuple function result of taking the argument of the list percepts. Got that? That's what that means in English, roughly speaking. Okay, so now our action is set equal to that. Let's see what the action is. Look at that. Look at that. Our action is thumbs up. Why? Because don't go too far. Because up here, when we gave the table, sorry, this is not quite as easy to do as in straight Emacs. We're using tmux tools here. So we defined in our table, which is a dictionary object, that if the agent if the percept history is just red, that's that first line here, okay? This first, don't do that. This first line says if there's a percept history of just red, the agent program should return the associated value in the dictionary, which is thumbs up. That set the action equal to that value of thumbs up, okay? So that's the action after when the percept history is red. Now, what if we do? What if? So our agent has, at this point, has basically seen one thing in its life history. Okay, so let's just talk for a second here. Our agent has just seen the agent that we're cranking the gears of inside ourselves as we're copying, pasting each thought of this agent's life because we're inside of its brain, John Malkovich style. This agent has woke up just now. And the only thing that it has ever seen is red, and the only thing that it understands is it had this sort of automatic reaction that it gave a thumbs up to the red. Okay, this thing is a baby. It's the most baby sort of thing. It's not a perfect analogy. You can't be too anthropomorphic about it. Okay, what's going to happen next? it's going to see red again. Let's see what that looks like. Okay. So we're going to go over, we actually don't need to copy that. We can just recall, okay. Actually, our percept is still set equal to red. So if I just append the percept again, it's this, what I'm doing right now, click. What I just did now is I appended the same percept to our percept history list. So now our percepts has two experiences of red, or two percepts of red. So our percept history is no longer just this red. It's now two reds, okay? What is that? Does that remind you of anything? Huh? If you look, I know that this isn't translating to podcast, but I'm going to figure out how to say all this in podcast in audio only. But for right now, that corresponds to that up there. I know you see a lot of parentheses and stuff there. Let me tell you about those parentheses later. Oh my God! But I can't tell you about them right now, or we'll get bogged down. Okay, so what do you think is going to happen if we set the action equal to a lookup of the percept history in our table? That's what we're going to do again. This is the thing we're going to do again. We're going to set the action variable equal to the result of the get method applied to the table, and the argument we're going to give to the get method is the result of giving the percepts argument to the tuple function. And what do you think it's going to be? You want to guess? Can you guess? You should guess. You should guess. You shouldn't just wait to see because you shouldn't. Okay, what's the action? What do you think it's going to be? Yes, it's interested. It's very interested. Okay, now we got to do something different. Now we got to add our agent has to see something different. All this poor baby computer program has ever seen is two reds. It doesn't even know what's happening. It doesn't like that we're inside of its brain. Let's give it a green, okay? Now the percept is green, but the program has not experienced the green yet because we have to append that percept. The new value of percept, the new value of the variable percept is green. Now we're going to use the append method on our percepts dictionary to take that green and put it in our percept history. And now let's see what our percepts history looks like. Ooh, red, red, green. Does that remind you of anything? Does that remind you of anything? Of course it does. Okay, let's see if we did it correctly. Of course we did it correctly. You don't see any error messages, do you? Do you? Let's set action equal to a lookup, get method, blah, blah, blah. And our action is, okay, yes. Look at that. Look at that. We've definitely got the agent's interest at this point. What are we going to do now? Well, I think without typing anything, because typing's not good, we're going to set the percept equal to red again. We're going to, what do we do here? We append, right? Percept.append the percept to the dictionary list. No, not the dictionary, the list of the percept history, which is percepts. Let's just check percepts again here. Okay, red, red, green, red. Do you remember that from yesterday? Let's see. Let's set action equal to the lookup in the table. And now action, if we were to return it in a program, thumbs down. We did it. Wow. We built an agent that does what we want it to do. How cool is that? Okay. I don't know if you found that hard to follow, but you can go through it hopefully with the audio or with what I'm saying in combination with what you see. Saying that in audio, it would be, I mean, even if I just triple the number of words, we're gonna have to do it differently. But anyway, we don't have to work that out right now. Okay, so let me tell you about how I got to that. I think I spent about 5 hours making this work, and none of that was devoted to environment. I already had IPython. I already had everything I'm using environment-wise. The thing that, so it basically came down to a syntax problem. First, I had to strip away, I had to get off this. I had to get off the, oh, geez, I just banged into my own desk. The Python code that they have here doesn't oh, it doesn't. I'm sure it works for what they're doing, but they're doing things mostly. They're doing things in IPython notebooks, Jupyter notebooks, and it's meant to be done in this really GUI environment. This particular function, the table-driven agent program function, is not in their Python notebook, but it's written in a way that I can't really figure out how to pass percepts to the nested program function in here. So you see define table-driven agent program, and then you see that's the whole program function, and then below you'll see define program that takes the argument percept. That define program needs to get that argument percept. I don't know how to get it to it if I'm calling the code as they've written it there. So I'm going to show you how I do it in a second. First of all, I had to just figure out that there was nothing about this structure of this program that I had to preserve. So I just took the parts that I wanted and did it step by step the way that you just saw it. That was the first thing. And then the second problem was to do with this dictionary. Where am I? There we go. So basically I started out with, if you can see this, my key value pairs looked like this. I just basically had a string read, and then I used, this is correct syntax if you're just doing basically printing and input output at the command line. But if you're trying to use a tuple function to look up in a dictionary, you have to change your string a little bit, change your key value. And eventually I found that in another place they had done it with these parentheses and with this comma and nothing after it. And this is the correct syntax to make the agent, to make the lookup part of the program work. And so then it was just a matter of, okay, now we can do it with one percept, and now we just need to write a list of all the percept histories that we care about. And so that's these. Now you'll remember that in AIMA4e, or in the pseudocode as well, they say like this sort of program it does what you want, but you have to specify every single percept history. And of course, and like they say there's like an hour, they calculate how many, like the size of the percept history for like an hour of video or something. And it was like, way more atoms way more entries than number of atoms in the universe sort of thing. Okay, the combinatorial explosion. That's always, when you're just like methodically doing this, even if you could do it, there's no computer in the universe that could run it. There's no amount of time in the universe that could accommodate it, okay? But today we're not trying to learn, the best algorithms for doing artificial intelligence. We're trying to learn just how to implement, how to get computers to do what we want in the context of writing artificial intelligence code that's pseudocoded in AIMA and then implemented in Python on their website, on their GitHub. Okay, so what we just did, going back to the code here, is what you see here. I just sort of copied and pasted these steps. Okay, so this is working. Now what we're going to do is hide this, and we're going to look at the next, basically doing the same thing without all the copy pasting, okay? So let's go back over to IPython. We're going to reset so that there's nothing there. So if we do percepts, there's nothing. If we do percept, there's nothing. If we do, what was it called? Action, there's nothing. Okay, so we've cleared memory. So there's nothing over here. You could just exit and then IPython again, but it's more elegant to clear it. Okay, so we're going to give the same table. This is not good form in my text document over here. I've got the same table copied and pasted in 3 different places, but it's just for the purposes of this video, it makes sense. Okay, copy paste, put our percept history lookup table. This is the smartness of our program. Otherwise, it's not a smart program. It's still not smart, but it's a proof of concept. All right, we got our table in there. Let's check that our table's in there. That's good. Okay, now we're going to put our empty percept list. I always do this. I want the yellow copy pasty, not the blue copy pasty. Blue is Emacs, but it doesn't go out of Emacs. Yellow is Tmux, and Tmux is outside of Emacs, and it's really useful, but sometimes the key strokes are, they get confused in the mind. Okay, so we put our percepts, our table dictionary in there, our percepts list in memory. We're still inside of John Malkovich's head here, but we're not going to do so many steps after this. So instead of doing percepts, instead of defining the percept variable here manually and then running the append, and then setting action equal to the result of the lookup, and then calling calling the action variable or printing the action variable to the screen. We're going to just do all this in a program that we're just did it again. We're going to do it all in a program. This is our program. We're defining a function called program that takes the argument percept, and we're going to give it. We're not going to call it percept. We're going to just put it right into the program, right into the argument space for when we call the program, and it does everything we just did without all the hassle. And we're going to make it even better in a minute here. Okay, let's do program. Oh, look at that. It's auto-completing because it remembers I've done this before. So we're going to call the function, the agent program our agent program called program, because we like to be confusing. And we're going to give the argument red. Red is the percept, okay? So it's going to take this, it's going to take what we give it, and anywhere you see, it's going to treat it like this. It's going to call it a percept variable within itself, not externally, not outside the function. And it's going to put it here, and then it's going to be appended to the percepts list, and then that's going to make it so that it's the action, so it's able to look up in that table using the percepts list the action that it needs to return. Okay, so let's send red, the percept, to our agent program, and look at that. Much easier, right? Thumbs up from our agent program. Okay, this is the new version. The other one's dead. We killed it. Okay, but this new clone baby is much more. His life is moving much more quickly than the previous agent's life moved. Okay, so let's do the same thing. Oh gosh, I'm forgetting. Do I need to? Well, let's just see what happens here. Oh yes. Okay, so because it's updating the percepts list, I send it the same percept again, and now the percept, will it show me percepts outside of the? Yeah, it will. Okay, because I defined percepts outside of the function. So that variable is that container, which is a list, is global. Okay, not defined within the. Yeah, we're not doing any object oriented here. So okay, now what we want to send is not another red, but a green. Because if I send another red, I'll basically corrupt the percept history. I don't have an entry for red, so it won't have any action, and I can't really easily fix it. I could fix it, but I have to manually change the percept history. Let's just do it the way we intended. Okay. Ooh, agent program is still interested, but let's send it one more red, and let's get our big thumbs down, huh? You think it's gonna work? Of course it works. Of course it works. This is Retraice. Of course it works. Ooh, I can't think like that. I'm talking smack now. Okay, so that's much easier, right? This version of running the program only had 3 copy pastes. Okay, let's fold this. Okay, now let's try. Actually, this is the copy pasted. Okay, so let's reset. Yes, I want to reset. Okay, everything's done or cleared. Now this is copy pasted from the AIMA. So this doesn't work for me, because if I call the table-driven agent program and give it the table, fine, but I can't give it a percept. I don't know how to give it a percept. I can give the program function a percept, but the program function is defined within the table-driven agent program function, and I can't get to it. Now I can get to it, but I have to modify this code. I'll show you what I do. I don't know how. I don't know if I don't know why they wrote it this way. I'm sure they know what they're doing, but I don't know how to use this code as it's written here. This is called a nested function. You got a function inside of a function. The indentation is like braces in other languages. So this is really this stuff is all contained. I can't call program if I put this. Here, watch. Okay, so and I keep doing it. Keep doing this. Jeez. Oh, that's okay. You can do that. No. Okay, look. I'm just going to put this. No, I don't want to autocomplete that. All right, that's an IPython right now, and what's the easiest way? I'm just gonna. Autocompletion is awesome and also not great in IPython, so I have to do some of my. Okay, so if I give it, well, let's do our table here. I hope this makes enough sense to just follow. So I got to put my table over here in memory. Okay, so now if I, hold on, I got to do it again, don't I? Okay, this It's not ideal. Okay. No. No. There we go. Okay, now I'm going to give it the table. There, yeah. If I do that, I'm calling the table-driven agent program function. I'm giving it the argument table, which is in memory as table, and what the table is a container. It's a dictionary. It's an associative array, I think, is the data structure. And it's gonna look. Okay, that's not an error message, but that's not what I want. But I can't like do anything. Like if I try and give program, the program's defined, that's a function defined within table-driven agent program. And table-driven, I can't give table-driven agent program like, come on. Okay. I can't give it another argument because it doesn't take a second argument. Okay. So let's just accept that that's not working. So let's go over here. Now, hold and fold. Now let's look at my little kludgy hodgepodge. Okay, again with the table. Got to do it this way just for presentation purposes. Okay, so let's copy paste the table over here, put it in memory, and we got to do percepts outside of it as well because I couldn't get to percepts either. Clicky, typa. And now what I'm going to do, you can see what I've modified here. So I've changed table-driven agent program to table-driven agent program 3arg, and it takes 3 arguments. It takes the table, the percepts, and the percept, the PC. And the PC is the last thing that we're going to give it. So let's put this over here. You can see that table, you already know what table is. Okay, that's the dictionary that we've been talking about. You already know what percepts is. That's the that's what it's going to, when I put my argument there, it's going to assign that as the variable percepts, although it's going to be a container because I'm going to send it a list. And then finally here, this is where I'm going to put the red. Okay, so let's just watch it. Okay, so done. Okay, now table-driven agent program, no. I want 3arg. Oh, come on. See, it doesn't complete. Why doesn't it complete that? I don't know. Company mode. You need company mode for IPython. Okay, table is what we want to send to table-driven agent program 3arg. We want to send our empty list of our percept history, which I've changed the name of just to avoid confusion, and we want to send it red. Okay? Let's see if I typed anything incorrectly. Oh, thumbs up, it worked. Okay, let's send it again. Oh, it's working. Oh my gosh. Look at that. Okay, so I made it work, right? I changed the program so that it takes 3 arguments, and it's not elegant. I actually wrote in my notes over here that I'm not sure why the percepts doesn't get wiped out, but I do know that because I define it outside the I should just, actually this is, well, anyway, I'll modify it later. But it's because I define that list, or I initialize that list outside of the function. So it's modifying a list that's outside of itself. So that's why, actually, I'm just going to, why not write that? Actually, I got to take it out of read only because the list is initialized outside the function. Come on. Oh, I'm in. Oh, jeez. I can't. Why is it not? There we go. Okay. And so, yeah, that's it. Now you can see we've made it work in all the different ways that it should work. Step by step, every line of code we're doing it. We are the control structure. Then using a little bit of computer program function control, and then modifying their code so that it takes 3 arguments, but it's modifying, but the percept history is defined outside of itself so that it doesn't get clobbered every time. Hopefully that makes sense. Anyway, that took longer than expected, but you definitely know what's going on now. And if not, don't worry, we'll go over this stuff again, not this particular stuff again. Okay. Always be coding. If we're talking about player-oriented games, computer control game is player-oriented. It doesn't do a lot of good to read and feel like you comprehend something if when you sit down to make it happen, and I don't mean just copying and pasting it from somebody's repository or website. I mean really take it apart and put it back together and do kind of what I did here. I mean, I'm not like exhausting all of the unknowns here. There's a lot of code running that I have nothing to do with. We're at Python, very high level language. But all Python and any other high level language is just making binary and assembly is one level above binary, making it just easier to deal with. It's ultimately, it's all getting down to the hardware level, and we just build on each other's automation as coders. If you're not making things happen on computers, if you're not coding, if you're not always coding more or less, you're not going to calibrate. You're not going to get a good sense of your play on the field. It's like the difference between X's and O's on the sideline and cleats and shoulder pads if we're doing football, or shorts and a jersey, basketball sort of thing. If you're not out on the court, if you're not out on the field, there's a lot you don't know about what you can do. And that's what takes up most of the time too. Like, solving that parentheses problem, that syntax of the dictionary problem, was most of the problem that I had. Once I kind of quickly stripped away the code that they had written, I said, okay, listen, I don't know how to do this. I don't know why they did it this way. I can't spend forever on this. Oh, this is also, today is the first day I've ever done code on a real deadline, which is kind of awesome. It was bad at 5 o'clock when I thought, I have no idea how to make this work. Like, this is not doing what I wanted to do. But it feels good that I worked it all out and that I did it with plenty of time to spare. That's the realness. That's the real world. That's player orientation, and the game is player oriented, blah, blah, blah. Okay. That's it. I think like we'll get better at how to speak about these things for the podcast side of things as we go forward. But why am I saying that? It's already too long. All right. All notes and whatevers will be at retraice.com, retraice.com. We already talked about amendments and corrections. This is segment number 66. And same time tomorrow, 11 p.m., 8 p.m. Pacific. Signing off.